Hi everyone. This is an example of a limiting reactant stoichiometry problem. Here we go. We're going to follow our same 4 steps with a couple important additions. We're going to be able to find moles twice in step 2, and we have this extra part of our second step where we need to analyze our 2 mole answers while referring to the balanced chemical equation to come up with the limiting reactant. Our first step, however, is the same. Balance the equation, interpret the question. Here we go. In an experiment, 2.00 moles of propane is burned in the presence of 9.00 moles of oxygen. Determine the mass of carbon dioxide that is produced. We're always looking for some keywords when we're reading our question. Often looking for reacts with, mixed with, combined with. Here we have burned in. We can read the question again, focusing on those keywords. Propane is burned in the presence of oxygen. And carbon dioxide is going to be one of the products. We need to do what we need to do to come up with the balanced equation. Here, propane, we can find the formula in the data booklet if we're not quite sure what it is. It's C3H8. It's reacting in the presence of oxygen. It's being burned. It's hydrocarbon combustion. We get carbon dioxide and water being produced. We need to balance this equation. We take our time to do that, and we end up with 3 carbons on either side, 8 hydrogens on either side, and a total of 10 oxygens on either side. Here, 5 times 2 is 10 on the left-hand side. 3 times 2 is 6, plus 4 in total on the right-hand side, also 10. We have a balanced hydrocarbon combustion reaction. Let's get to our interpretation. We have 2.00 moles of propane. That's the moles of propane. So here's the propane, putting N 2.00 moles. We also have 9.00 moles of oxygen. Under the oxygen, we have the moles, 9 moles. The question itself says, determine the mass of carbon dioxide that is produced. We're looking for the mass of the carbon dioxide. Here's the carbon dioxide. It's the mass, M, and we're looking for it. Wherever the question mark is, that's R. All that is our interpretation, and now we can find moles twice. Find moles twice. We have enough information to find the moles of both the reactants. Here, we're going to be reading, doing mass over molar mass, or doing C times V. It's highly, highly unlikely, as a matter of fact, we're not going to see it, that we're using Avogadro's law or the ideal gas law in this step. So here I can find moles twice just by reading, no problem, 2 and 9. Okay. Now I need to compare those 2 numbers while referring to the balanced chemical equation in order to decide which one is the limiting reactant. Which of the 2 reactants is going to run out first? This is at 2, 9. But what the equation says is that 1 mole reacts with 5. 1 mole reacts with 5. So I'm just going to go like this. I'm going to use P's for propane and O's for oxygen. Here I'm going to put 2 P's. 2 P's, and then I'm going to put 9 O's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, normally we wouldn't be doing all this work. We would just be thinking about these numbers in our mind. However, because this is our first example, let's take it slow. 2 and then 9. P's for propane, O's for O. And let's work out the reaction. 1 reacts with 5. So the first time through, one of these P's reacts with 5 O's. 1, 2, 3, 4, 5. Now, The second P would also react with 5, but we don't have it. 1 full mole is going to react with 5. I have a full mole of propane. Here there's only 4 O's left. What that means is that the oxygen is going to run out before the propane. Here, 1's going to react with 5, but there's only 4. So these 4 aren't going to use up that full mole of propane. That means that we've thought about it. It's not easy. We've made a decision that the oxygen is the reactant that's going to run out first. It's completely consumed. All of these 4 O's are going to get used up, but not all of that propane. There's going to be some propane left over, but the oxygen is gone. It's the limiting reactant. All that was our step 2. We found moles twice. Here by reading, we analyzed the 2 mole values while referring to the balanced chemical equation to make this decision. It's the limiting reactant. Once we decide on the limiting reactant, we're going to use it for the rest of our stoich. It's a little bit repetitive to rewrite the moles, but that's okay. So we're using the limiting reactant. We have our 9 moles. We're using it as our starting point for the math. That means not only is it the limiting reactant, it's the given for this particular question. After I decide that this one's limiting, I'm totally ignoring everything about the propane. To answer a question about the product, it's the limiting reactant itself that matters. So this is now multiplied by R over G. That's 3 over 5. And all of that, like always, is our red N. No change there. After we multiply by R over G, we're at the red N. The mass is the red N, the moles of the required, multiplied by the molar mass. Here we're going to multiply by the molar mass of carbon dioxide, which is a carbon, 12.01, plus 2 oxygens, 16 and 16. This is 44.01 grams per mole. I have that all set up now. I can go and push the whole buttons. 9 times 3 on 5 times 44.01. That equals 237.654. The number that I used from the question was the 9, which had 3 significant digits. So I need to round off my answer so that likewise has 3 significant digits. And this was the mass that we found. The telltale sign that we have a limiting reactant question is that we have enough information to find moles twice. In this question, we found moles twice just by reading. It's not going to be unheard of for us to do some calculations. Most of the time, honestly, mass over molar mass. Sometimes, though, C times V. Once we have the 2 mole numbers, we need to compare them while using the balanced chemical equation to decide which one's going to run out first. The one that runs out first is the limiting reactant. We're going to use it to do the stoichiometry to answer any kind of question about the product. I hope that helps.